How to use an oscilloscope, electrical engineering basics. If you have ever wondered how engineers visualize electrical signals, you are in for a treat. An oscilloscope is the tool that makes this possible. It displays electrical signals as a graph of voltage versus time, allowing you to see what is happening in a circuit in real time. Let's break down how to use this essential instrument effectively. First, you need to understand what the display shows. The oscilloscope screen has time on the horizontal axis and voltage on the vertical axis. This setup helps you measure important signal characteristics like amplitude, frequency, and waveform shape. Next, you will want to connect the probe correctly. Attach the oscilloscope probe to the point in the circuit where you want to measure the signal. Make sure to connect the probe's ground clip to the circuit ground. This step is crucial for accurate measurements and helps avoid noise or damage to the equipment. Once connected, it's time to adjust the vertical controls. Use the vertical scale control to set the volts per division. This setting adjusts how sensitive the oscilloscope is to voltage changes. Position the waveform vertically on the screen for better visibility. Now, let's move on to the horizontal controls. Adjust the time per division to control how much time is represented across the screen. This adjustment allows you to zoom in or out on the signal, which is especially useful for viewing fast transients or slow periodic signals. Setting the trigger is another important step. The trigger stabilizes the waveform display by synchronizing the oscilloscope sweep to a specific voltage level or event in the signal. Proper triggering prevents the waveform from drifting and gives you a steady display. Once everything is set up, you can interpret the waveform. Measure voltage levels by counting the vertical divisions and multiplying by volts per division. For time intervals, count the horizontal divisions and multiply by time per division. To find frequency, calculate the inverse of the signal period, which is the time between repeating features. Analyzing the waveform shape helps you identify signal types like sine, square, or pulse and detect any distortions. Many modern oscilloscopes offer advanced features. You can use cursors for precise measurements or math functions to analyze signals. Digital storage oscilloscopes can capture and store waveforms for later analysis, which is very handy. In electrical engineering, oscilloscopes are used for various practical applications. They help debug circuits by observing signal waveforms and identifying faults like noise or timing errors. You can measure signal parameters such as frequency and rise times, and verify the correct operation of components in your designs. Using an oscilloscope involves connecting the probe, adjusting the vertical and horizontal scales, setting the trigger, and interpreting the waveform. Mastering these basics is essential for anyone working in electrical engineering to test and troubleshoot electronic systems effectively.